Hello everyone and welcome to our channel, Moo Techie. A special welcome to all the dairy technologists and students beginning this new journey with us. This is the start of a brand new series and this is Class 1 in Dairy Engineering. Today we are stepping into the critical and foundational world of dairy plant sanitation. Our topic for this class is sanitation. In dairy engineering, sanitation encompasses the engineering materials we use, the sanitary features we design, the pipes, fittings and gaskets we select, and the cleaning basics we must follow. This includes understanding systems like can and bottle washers, and the essential clean-in-place (CIP) cleaning processes. To understand why this is so important, let's look at the milk supply chain. Milk travels from the milk shed to the chilling center, to the main dairy processing plant, then to the milk shop, and finally to you, the customer. At every single step of this journey, sanitation is paramount. This leads us to a vital question. Is our food safe? Unfortunately, history shows us that when sanitation fails, the consequences can be severe. There have been numerous cases of food poisoning linked to dairy products. For instance, a simple online search reveals many reports, like one from Pennsylvania where raw milk was found to contain listeria, causing serious illness. Symptoms included fever, muscle aches, nausea, and diarrhea, particularly affecting vulnerable groups like pregnant women, the elderly, and those with weakened immune systems. The news headlines tell a sobering story. We've seen global recalls of baby milk over salmonella fears, fake baby milk formula scares, and major outbreaks. One devastating case occurred in Japan, where over 11,000 people were poisoned by tainted milk from a production line where bacteria accumulated in a valve. This was the largest outbreak of food poisoning in Japan since records began in 1975. An analysis of food recalls shows that nearly half, 47%, are due to microbiological contamination. 26% are due to labeling issues, 13% from processing defects, 7% from physical contamination, 6% from chemical contamination, and 1% from unapproved ingredients. The Centers for Disease Control (CDC) has conducted studies showing a clear increase in raw milk-associated outbreaks as more states have allowed its legal sale. These studies found that the number of outbreaks has increased, children are at the highest risk, and that sales in one state can lead to outbreaks in neighboring states. The evidence is clear. Consuming pasteurized milk is a critical public health measure. This is why sanitary and hygienic design is non-negotiable in a dairy plant. This applies to the entire dairy plant line, all processing equipment, pipes, fittings, valves, and every other piece of milk handling equipment. So what is sanitary or hygienic design? It is the selection of appropriate materials of construction, the design itself, the fabrication method, and the operation of equipment. The goal is to ensure the absolute safety of milk and its products from microbial and all other forms of contamination while preserving the highest quality. The materials we choose for constructing dairy equipment are the first line of defense. We have surfaces that contact the product, like plates, pipes, and tanks, and non-contact surfaces like supports, insulation, and protective coverings. Selecting the right materials for engineering purposes depends on several factors. We must consider the availability of the materials, their properties like strength and corrosion resistance, their chemical resistance to cleaning agents and disinfectants, their steam resistance for CIP and SIP processes, the hydrophobicity and reactivity of their surface, their suitability for the working conditions like temperature, and of course, the cost. Engineering materials are broadly classified into metallic and non-metallic. Metallic materials include cast iron, wrought iron, steel, aluminum, zinc, tin, brass, and copper. Non-metallic materials include glass and various plastics. It's important to note that basic iron is never used where it has direct contact with food. Iron combined with carbon makes steel, but we need to understand the different types. Cast iron contains 2 to 4.5% carbon. It's difficult to weld and brittle, used for heavy equipment beds. Wrought iron has very low carbon, is easily welded and tough, used for chains and hooks. Mild steel is highly ductile and strong, used for structural elements. The star of the dairy industry is stainless steel, which is steel plus chromium, along with other elements like manganese, phosphorus, sulfur, silicon, nickel, and molybdenum. The food-grade stainless steels are SE304 and SE316. AISI 304 is the basic grade for non-acidic food contact and external machinery. It can corrode with prolonged salt exposure and is used for pipes, tanks, and silos. SE316 is for high acid uses and is more heat and salt resistant. It's used for plate heat exchangers, CIP tanks, and evaporator tubes where higher corrosion resistance is needed. The chemical composition of these steels is precise. For example, both have low carbon, manganese for wear resistance, and chromium for corrosion resistance. Se316 also includes molybdenum for even greater corrosion resistance. We use these grades because the passive film on their surface prevents contamination and bacterial growth. They have good corrosion resistance, higher creep properties, are easy to clean, protect flavor, and are environmentally friendly. We also use non-ferrous metals like aluminum, prized for being light, corrosion resistant, non-toxic, and not imparting flavor. It's mostly used for milk cans, though the trend is shifting to stainless steel for better hygiene. Aluminum can be porous, difficult to weld, has poor abrasion resistance, and can give a gray stain. Anodized aluminum is easier to clean. Tin is a soft, malleable white metal used as a protective coating for iron and steel sheets and for making moisture-proof tin foil. Other metals like brass and copper are not used with high-fat foods because they accelerate oxidation. They are more common in breweries. Plastics are synthetic materials molded into shape. There are two types: thermosetting plastics, which have chains cross-linked by strong bonds, and thermoplastics, where the chains are easier to separate. Examples include Teflon, HDPE, LDPE, PVC, and many others. Plastics are extremely corrosion resistant and dimensionally stable, with an upper temperature limit of 250 degrees Celsius. They are used for coating, ventilator parts, pump seals, pipes, fittings, small tanks, and gaskets. It's important to note that plasticizers are undesirable in the dairy industry. Rubber and elastomers resist abrasion, heat, and strong chemicals. They are used for gaskets, seals, pads, and in parts that withstand friction, like pumps, and for coating metals. Glass is resistant to acids and can withstand high pressure, though it is sensitive to bending. It is used for coating vats and for sensitive products in pipes and equipment. Finally, ceramics and materials like polyester resins, reinforced with glass fiber, are used. They are chemically resistant, have good strength up to 130 degrees Celsius, and are used for fittings, valves, and vats connected to plastic pipes. Thank you for joining us for this first class on dairy engineering. We have laid the essential groundwork by understanding the crucial role of sanitation and the materials that make it all possible. This knowledge is the foundation upon which safe, high-quality dairy products are built.